Good morning, everyone. So, in today's topic, von Neumann architecture. So, we all know that any computers or any smartphones or any laptop definitely will have a central CPU processor inside your devices, right? So, devices are normally having a processor. The processor basically classified into two types. So, any processor can be classified into two types. One is von Neumann and another one is Harvard architecture. So only the design is different, but the basic process is entirely same for the two architecture. Okay. So before going deep into the von Neumann architecture, we have some recap about the previous classes. Right?
So in the previous class we discussed about general topics like CPU, memory unit, input and output. In CPU there are two main components, ALU and control unit. ALU is arithmetic logic unit which will function all the arithmetic and logic functions in the command. And memory unit acts as a memory. And input and output devices, we all know, we have discussed some of the basic input and output devices. That's all about the previous class.
So this is your basic structure of any computer. Okay, there will be input device like keyboard, mouse, and output device that has to see the result, that is monitor, and inside that you will be having ALU control unit. Control unit controls entire operations. Okay, so in von Neumann architecture or any CPU architecture or any embedded architecture, you can take, for example, your mobile phone or any laptops or recent smartphones having an ARM processor. Okay, so this ARM processor having this von Neumann architecture design inside your mobile phones. Okay, so how the designs are actually? So the designs are actually like this only. The CPU will be having control unit and the logic unit. Then you have memory. So the main concept lies in this between CPU and memory. Okay, so in memory you will store all the values. For example, whatever the program you are returning in computer, everything will be stored in your memory. For example, if you want to do a text message, and your message, your phone has to pick up only one message at a time. For that, you will be having a program inside it. So all the program will be inside your memory. So in this memory will be split into two types: so program memory and data memory. For example, you are going to do some operations, addition operations, or loading operation, or moving operations. So you will be having instructions like that: add, load, move. So in this is called instructions. Only the instructions will be stored in this memory. Instructions like add A comma B is an instruction. You are instructing computer to add two data and store in the some same A value. Okay. Similarly, move A comma B means you are instructing your computer to move data from B to A. Okay, like that you will having instruction will be stored in separate memory, and the data like values. Okay, A value 5, C value 6. So everything will be stored in the separate memory. So between these two memories, you are using common bus. Okay, this is your bus. Bus is nothing but it is used to carry information from one place to another place inside your computer. Okay, so inside your computer you will be having a bus. This bus takes information from one place to another place. So what happens here in von Neumann? So this scientist has found that the program memory and data memory sharing the common bus. Common means in the same bus you have to travel the same program or instruction also and the data also. For example, you are giving add A comma B as an instruction for your computer. So what your computer has to do is first it has to read this add A comma B instruction. Then it has to go to the data memory and takes the value from the data memory. A value, B value it has to take. That is called fetching. Okay, the CPU will do the fetching process from the data memory. So this instruction will travel in the same bus. Then this data is also traveling in the same bus. Okay, that is the concept of von Neumann architecture. Okay, we are not using separate bus, we are using common bus. This is the word we have to mention in the paper while writing the exam. Common bus or sharing bus between program memory and data memory, which is called von Neumann architecture. Okay, so here in this memory, so you will be having common bus. So common bus use for what is the problem you are having? Because if you are fetching a data, the program has to wait. you are doing operations on program, the data has to wait. Okay, so simultaneously you are operating with two members, so one member has to wait while doing operation with other members. So this is the main concept of your von Neumann architecture. So here read this, both program and data memories as common bus. This is the bus. You have to draw this symbol. Okay, this is a unidirectional bus. If you draw like this, it's a bidirectional bus. In the same bus, you can send the data and you can also receive the data. But here I am drawing only the unidirectional bus. So in this way, you have to send. In this way, you have to receive the information. Okay. So in the memory, you will be having two program memory left side, data memory. What I have drawn there. So program memory, data memory is there. So both will be using same bus here. So that's why this is called von Neumann architecture. Then operations are sequential. Sequential means one by one. Simultaneously, you cannot fetch the data and instruction same time. One by one only you have to do the operation. So you have to wait. You cannot fetch instruction and this is the main point you have to note down. Okay. Then what are the advantages? If you are using the common bus means you don't need to pay for another bus. You don't need to implement or you don't need to use another bus, so your cost will be reduced because you are sharing a common bus, right? Then what is the disadvantage? Delay. Okay, for example, வீட்ல வந்து you have a mother, father. அப்பா இருக்காங்க, அம்மா இருக்காங்க. அப்பாக்கு தனி கார், அம்மாக்கு தனி கார். ரெண்டு பேருமே வேலைக்கு போறாங்க. கரெக்ட்டுங்களா? அப்ப என்ன ஆகும்னா உங்களுக்கு டிலே இருக்காதாங்க. அவங்க நினைச்ச நேரம் அவங்க கிளம்பி வேலைக்கு போயிடலாம். அதே மாதிரி அம்மா நினைச்ச நேரம் அவங்க நினைச்சு கிளம்பி போயிடலாம். பட் ரெண்டு பேருக்கு காமன் கார் தான் இருக்கு. ரெண்டு பேரும் வேலைக்கு போனா அந்த வேற டைம் என்ன பண்ணுவீங்க? So you are using common bus. அப்போ ஒரே கார் தான் யூஸ் பண்றாங்க உங்களோட பேரண்ட்ஸ். அப்போ வந்து அப்பா கூட்டிட்டு வர வரைக்கும் அம்மா வெயிட் பண்ணணும். அம்மா கூட்டிட்டு போயிட்டு வர வரைக்கும் அப்பா வெயிட் பண்ணணும். கரெக்ட்டுங்களா? The same concept here. The von Neumann architecture using the common bus for both program and data. Okay, but in future, after this invention of von Neumann, Harvard, another scientist, okay, he designed one concept with the same concept, but he used different buses in this place. Okay, one bus for program, one bus for data. Okay, one bus for program memory ki tani bus, one bus for data memory tani bus. So separate bus use பண்றாங்க. in architecture la Harvard architecture. That is not in your syllabus, but you have to know. Okay, in your syllabus you have von Neumann architecture. This is very important question. So what you have to do, write the title and you have to say what is von Neumann architecture. So von Neumann architecture uses both common bus for both program and data memory. That's all. Then you have to draw this diagram. In CPU, we all know that input devices are keyboard and mouse. We are used to instruct the computer. We use those devices. In order to see your result, you will use monitor as a screen. Okay, output devices. Inside that, your control unit will control. What is the main function of this control unit is nothing but for this CPU, it goes to memory and takes instruction and give it to CPU. Instruction போய் மெமரியில இருந்து எடுத்துட்டு வந்து CPU க்கு கொடுக்கிறது தான் இந்த கண்ட்ரோல் யூனிட்டோட வர்க். புரியுதுங்களா? அதுக்குள்ள இருக்க ஆபரேஷன் பெர்ஃபார்ம் பண்றது லாஜிக் யூனிட். A, B, மல்டிப்ளையா, டிவைடா, அடிஷனா, சப்ட்ராக்ஷனா அப்படிங்கறத பார்த்து பண்ணும். Once the operation is done, it has to store the result. Result ஸ்டோர் பண்ணணும் இல்லையா? இப்போ A plus B 5 plus 6 11 ஸ்டேவ் பண்ணிட்டு 11 கொண்டு போய் again stored in memory. அப்புறம் எப்போ கண்ட்ரோல் யூனிட் தேவையோ அந்த 11 வந்து either நான் வந்து மெமரியில ஸ்டோர் பண்ணி வைக்கலாம் இல்லைன்னா at the timeலயே டிஸ்ப்ளே பண்ணிடலாம். புரியுதா? எனக்கு அப்பவே ரிசல்ட் வேணும்னா அவுட்புட் டிவைஸ் கொடுத்துறோம். இல்ல நான் ஸ்டோர் பண்ணி வச்சுட்டு அப்புறமா ரிசல்ட் அப்படி எடுத்துக்கிறேன்னா மெமரியில கொண்டு போய் ஸ்டோர் பண்ணி வச்சு. இதான் வந்து இந்த CPU பண்றது. ஓகேவா? Then memory you are having two types, program memory, data memory. Program memory, so instruction will be saved. Data memory la data will be saved. Okay, so this is the bus. What is a bus? Bus is a device which is used to take information from one place to another place. Okay, so that's all about your von Neumann architecture. The main advantage is cost effective. The disadvantage is it provides delay because at the same time you cannot do the operations. Then your advanced model of this von Neumann architecture is your Harvard architecture. So you can also do some changes in this design and you can create a new architecture also. Okay, in future scope. So that's all. Then we have a summary from Sarana.
Hi guys, I'm here to summarize today's class. Today we have shown about von Neumann architecture. Von Neumann architecture uses a common bus to transfer the program memory and the data memory. The operations are sequential, in which the operations are done one by one, and we cannot fetches the instruction and the data in same time. The advantages it's cost effective because we are using a single bus, and the disadvantages are the time delay. Yes, the advantage, common bus is a disadvantage. Thank you.